Can you hear me?
Yes.
Okay. We can start. So we'll now we will start to create a code for the flash memory. So I will share my screen. I hope you can see my screen. Okay.
Yes.
Okay. So what we are going to do now is we are going to create a library for the flash memory. So the first thing we need to know, we need to find. Okay. Before that one, I'll explain something else. Okay. So we have the PIC IC, and we connected that one to flash memory. So we have MOSI, so data go in this direction, MISO, and clock source is, and we have the chip select pin. Okay, so the way we do things in this flash memory using this SPI port, we have to command to the flash memory from the PIC IC. Let's say if we want to get write some data byte here, first you need to tell to the flash memory you are going to write some bytes, and then you have to send the starting address, byte address, then you have to send the data. So the flow will be like this. First you have to tell to
Tell the
FM.
FM we want to send the data.
No, you need to tell the you have to say, tell to the flash memory you are going to write data. So basically it's a command. So you have to tell it, FM, you are going to write. After that one, you need to send byte address. Send byte address. Then third one is data. Whatever data you are going to write. So here you have first you need to command to the flash memory. So you need to know what are the commands. So if you go here to data sheet of the flash memory, somewhere below you can find the command list. It's very far away. Here, command list. So there are command reset enable, reset memory, read ID, multiple IO, read. So many things are there. So I will show how to do this thing. Okay, how to use this table. First, after you connect the flash memory, you have to make sure whether this flash memory correctly connected here. Okay, actually in the PC, in the circuit, you have connected it correctly. Let's say you develop a breadboard model or something. In that case, you need to make sure these lines are correctly connected. The way we do is, there is the option you can ask this flash memory ID. You send a command and flash memory reply with the ID. So which means your SPI and this connection is correctly uh, configured. So first function we need to write is the read ID function. So let's see how to do it. Okay.
Okay.
So the first thing you need to create the CCS project. I do some weird method. I don't use the entire program to like. I don't start from the beginning. What I do is I just create a text file. Okay, let's say uh, you can just name it as you like. Okay, it main. So instead of dot text, I just rename it as dot c. If you have if you have the compiler, its icon change to this icon. So this is just an empty text file. If I double click, it will open using the our compiler. Otherwise, you have to go file and then create a new project. You don't need to do that one if you go like that. So if you don't see this icon, you just go here, open it, and select the compiler. Okay, and then you have empty text file. So first thing you need to do is you need to include your IC, the IC you are going to use. Can you see the letters properly? Should I make it little bit bigger? I'll type and then tell me. Okay.
So far can see.
Include. Can you see this?
Yes.
I can little increase if you need. Okay, if you can see, no problem. Then I have to include the IC. The IC I'm going to use is 16F1789. So you have put .h. You don't need to remember these things. Just copy and paste or just use the old code. Okay. And then you need to put this function fuses. And you need to put, you must this MCL, sorry, no, no, actually, we need no MCLR and no watchdog timer. So these two lines means I am not going to use a MCLR pin as a reset pin. So that's what I put as no MCLR. It's actually not so important. No watchdog timer means I don't use the internal watchdog timer. Okay, that's it. Then you have to specify the crystal you are going to use. So this is the line. Please don't try to remember these things. Just things we use. Just copy from my old code. Okay. Use delay. You need to tell how much crystal you connected here. Okay. First of all, I need to open the. No, here I can show here. So our crystal is 16 megahertz. You can see here. Okay. The way we say is just put crystal equal 16 megahertz. Okay. Then you need to open the main loop. Okay. Void main. Actually, this is enough to compile. So just to check whether this is being compiled, let's try to compile. So it's compiled correctly. So in the compile tab, so maybe you can see here. Wait, I need to see my screen also. Then press the compile. So it's compiled correctly. Then we need the continuous loop. So while loop. So while you can say put true. One more thing, In this compiler, it don't care the capital or simple. It's not case sensitive. Okay, no need to worry. Just you can just put anything. It's not like C double plus or something. So now I have the basic structure of the code. Let's try to create the library. So instead of writing the function here, I go to the file. So I'm going to create a separate .c file for the library. So I go to the file and source file. It will show my folder. So what you have to do is you can give any name, okay? fm lib.c. So you have to save like that. I just copy this one, save. It will open a different C file. So then you need to include this one into your code. Include so let's see. Since there are nothing, it is compiled correctly. Okay. Then let's go to the this library file. So here is where we are going to create the library. Okay. So first of all, you remember in this one, you need to define the SPI port. Okay. Now I am going to define the SPI port. First of all, let's do something here. Let's define Mosi Miso pin now. So hashtag. So here, defining pins. The first pin we are going to define is Mosi pin. So what was the Mosi pin in our case? Mosi pin was here D6. No, D7. Pin D7. These are syntax in this compile. Okay, so you have to tell like pin D7 and then define miso pin. Okay, miso pin was D6 pin this D6 and then hashtag define CLK clock pin, that is pin I'm not sure, clock pin is D4 and then hashtag. Actually this is kind of a giving some variable, defining variable. Okay, still we have not defined the SPI port. Okay, so this is chip select. So it was pinned D5. I just compile, no need to do every time. So then here we are going to define the SPI port. Defining. Can you hear properly?
Yes, proper.
Okay. Okay, thank you. So here I'm going to define the SPI port. You don't need to remember this one. So get from all code. So the way we define is use SPI starter bracket. So we have to tell whether it's a master or slave. So we say master. Then we have to tell the clock pin. I don't like this method because let's define like this. Just a different naming. Okay. Clock pin is this one. CLK2. And then I have to tell data input pin of the master. That is actually miso. So basically what you can do is you can take this instead of defining this entire set, you can just put it here, okay? No issue, but I don't like that method. So then the data out pin. So that is MOSI pin. MOSI. And then you don't need to tell the chip select pin, okay? We will control it by ourselves. Then the data rate, baud rate. So let's use 1 Mbps. Okay. Then you have to tell how many bits you are going to use for the SPI. So SPI can have to like 16 bits SPI or 8-bit SPI or whatever we can use, but in this one we have to use 8-bit SPI, which means every time we send only one byte to the flash memory. Byte by byte we send to the flash memory, okay? Then we need to tell this SPI port name, okay? Stream. Okay, let's give like FM1. We give flash memory name is FM1. Okay, let's say it is, since it's comp flash memory, let's say it's CFM. And then there are modes in the SPI, okay? If you read, but I did not explain those modes, you don't need to know actually. Just put mode 0, this flash memory support mode 0, okay? This is how we define the SPI port. If we compile, if we don't have error, it should compile. So you can see these lines in the codes. So you just need to copy and paste, and you can adjust your pins. Just putting here. Okay. If you are clear here, please. Is it okay?
Yeah, okay.
Okay. Now let's try to write function. Okay. Okay. The first function we are going to write is read ID function. So if we go to the day, not this one here, read ID command is 9E, okay, 9E or 9F. So if you send 9F, this everything's a hex, okay? It will reply with 20, 0x20, okay? So I remember that 20, that's why I just said, okay? Then what we need to do is first we need to write the function. Since this one is going to return something, we need to tell what kind of value will be returned in this function. It's an unsigned int, int 8, since it's going to return. So read ID. So this is the function we are going to write. Okay. Now let's see the first thing we need to do. As you remember, I said you have to make the chip select pin low to communicate with this flash memory, and after communication you have to take it back. The first line you write is you have to make the chip low, no, chip select pin low. So the way we do is, in this compiler, if you want to, we are going to make this
CS.
pin CS low, okay? The way we do is, yeah, output low, okay? Very simple. Then put the CS. Okay, done. So then you need to send the command to the flash memory. The way we do is, there's a function called XPI expert. Okay, this function is used to send and receive both. Okay,
Send and receive both
yeah, both we can use. There's no SPI transmit and receive. Both function are
Okay.
combined together. Okay,
Transfer. Okay.
XPI expert. So you can see here, you need to tell stream name. You are going to send into home flash memory and the command 0x9f. This is the command. After that one, if you like to delay, you can delay. Okay, little bit delay, like maybe it will take some time to respond, but this flash memory is very fast. You don't need to delay actually. But what you can do is, you are going to get a data from, you are going to create a unsigned int 8 variable. Okay, let's say respond response. Okay, so to read the incoming data, you have to use the same function. Okay, SPI expert. Here you don't tell, you just tell the stream only here, because you are not going to send any data. That's how you read it. Okay, so then since we have the data, what you can do is return the response. It will return the response.
The response.
Okay, letters are wrong.
Wrong also.
Okay, I'll correct it. Maybe yes, not S. I don't care the spelling here, just variable.
It doesn't
okay?
mean one, is it? This time. Just,
Huh?
I mean, oh no. So it's okay. It's okay.
Yeah. So it's okay if you just put like.
If I say wrong, then you, as long as you spell wrong, also never mind, right? Because we have defined it.
If you do something like this, it's okay.
It's okay, right?
So, yeah. Just you need to get the response.
Yeah.
Okay, done. So the way you do is, way you use this function is, go here in the while we use f print. So we need to define a UART port if we want to use this fprintf function. Okay, we need to define a UART port. Let's define a UART port also. Sorry, I forgot to do it. Somewhere here we can define. Somewhere here it's similar. Hashtag use rs232. You can see this function. Okay, I'll quickly write this function. Baud rate. So baud rate is 19,200, and then parity. I'm not going to explain these things. No parity. If you read about UART, you can find what is parity, and then you need to tell the transmit pin. It's xmit. I'm not sure what pin I will use. So let's say RB pin V7. Okay. I'm not going to write a receiving pin. You can go with only transmit pin if you are not going to receive anything. Okay, then here also you have to tell how many bits. Bits 8, and the port name stream. Let's say this is debug port. Okay, the way we use is, let's compile and see with this. Okay, so the method f print f, this is the C method. So then you have to tell port name. Port name is debug. Then here flash memory ID. Flash memory ID equal. You have to put this one since you are going to print a 8-bit value, that is plus capital X. Okay. Then you need this new tab and the next line function. You can read these things in the C. So these are some syntax. Then put here read ID. So if you let it run, this will print very fast. Let's delay a little bit. Delay millisecond. Let's say 1000 millisecond delay. Okay, here. Okay, it's like that. Okay, it will print. It will print like this. FM FM ID. Okay, I'm not sure what I print there. Okay, let's say FM ID equals 0x20. After 1 second, it will print again FM ID equal 0x20. If the connection is correct, it will keep going. Okay, understand? So that is the first function we wrote for the read ID. Then there is the special function we need to write, that is write enable function. Okay, that write enable function, you need to first find what is the command. Somewhere here you will be able to find the write enable function. Here write enable is 06. You can see. First you need to write the write enable function. Okay, that function will not return anything since it's void. FM write enable. So the command was 06. One more thing you can do here. It's a very good practice. If you can do something like this. Define ID read. You can put the commands here 0x9f. So I put this one here. You can do like this, okay, if you like. And here what I do is one more thing I forgot here. I make the chip select pin low, but I forgot to take it back before returning the data, so I have to take it back. So make it high. Output high. Okay, understand? So the first thing, then next time also you have to do output low. Select the chip and we have to transfer 06. So we have to transfer 06 then and take back this. Okay, we wrote the write enable function. Until now, no problem. Can you please tell me? Is it okay?
Okay.
Okay, then we need to write the sector erase function. For sector erasing, you must send one address inside that sector. Okay. Normally we send a starting address of that sector to the flash memory to tell this is the sector you need to erase. Okay.
Okay.
So the function is, you can give any name, no need to worry like about this one. Void fm sector erase. Before doing the sector erase, we need to send, we have to run this function, write enable function. Okay. Then there's something you need to know.
We need to write the enable function because we want to copy out before we erase, is it?
No. It's just telling you are going to write something in the flash memory. Actually, sector erasing also writing,
Okay.
because you are going to write a 1111. Some you must do this. So then now you need to, the function I am going to create like this. So my function should look like this. Sector erase. I should be able to put the start address, some start address, and sector size. Okay, 4 KB or 32 KB or 64 KB. My function should look like this. So this is start address, and then this is sector size. So I need to create a function like that. So since I want to create like this, I need to, I should be able to load those values here. So unsigned int, our address is 32 byte long. Because of that one, I need to be able to put 32 byte long value here. I put here add, and then int. You don't need to worry about this value because it's 4 and 32 and 64. I'm going to put, since I can put like this, since not since, like int sector size. Okay, this is my function. So then you need to understand something now. So the first thing you need to do is you need to send the sector erase command. Okay, then you need to send the start address. Okay, so you know sector erase function command is just, if you find somewhere here, here sector erase operation, 4 byte sector erase, no sorry, okay, 4 byte means, okay, forget about this 4 byte case. Sector erase is DC. 4 KB subsector erase is 21. 32 KB subsector erase is 5C. Those are the command we need to send to tell we are going to erase sector. So those are 8-bit values, no issue. But this value is something like this. It's a 32-bit variable. You cannot send a 32-bit variable using 8-bit SPI. You have to extract this part by part. First, you have to send this one. Next, we have to send this one. Next, we have to send this one. Next, we have to send this one. This is how you have to send, okay? So before doing that, let's try to extract those byte by bytes, okay? Actually, I can do before this one also, because this is a function for us. So we need 4 variables. You can write something like this, and those variables are 8-bit variables, okay? Okay, let's say, how to say, ADD part 1, first part, and then ADD part. Oh, I can just define array here. So let's do that one. Otherwise, it will get confused. So what I can do is I can define a array called address. So it will have 4 elements. So the address 0 will be this one. Address 1 will be this part. Like that we can go, okay? Oh, we can go like this, but okay, let's define address. So it's a 4-element array. So then first element will be, first means 0th element, address, zero. Do you understand this one? Can you tell me? Maybe I make it little complicated. Should I explain again? Please tell me, someone. Can you hear me?
Yes.
So should I explain it again?
Not sure. Maybe yes.
Okay. Okay. So I said first you need to send the sector erase command. It's a 8-bit, no issue. But when you send the address, you cannot send this 32-bit address using 8-bit SPI, since we have to extract part by part. To do that, to extract that one, I need 4 variables to save those parts. Okay.
Okay.
So that's what I'm going to do. Okay. Instead of using this one, let's use ADD part 1, and then ADD
Part 2 until part 4.
Yeah. Let's go like that. It's simple. Part 2, part 3, ADD part 3. Okay. Now I am going to First do the extraction, then we do the command into the flash memory. So where is my mouse? So the first part I'm going to extract. This first part means this part, okay? Okay, this is how I do. Okay. 0x, let's say AA, BB, CC, DD. Finally, I need ADD part 1, ADD part 1 as 0xAA and ADD part
Part
2
1
as
to
0. Yeah.
DD. Mm.
This is what I need. So I need to extract those things, okay?
Mm.
Yes. Do you remember? I can move this part to this direction. How many bits I need to move? Can someone tell me? Let's say this variable is ADD. How many bits I need to move? If I do this one, ADD 24. So I said one letter is 4 bits, 6, so which means 24 bits. So your value will be, new value will be AA, DD, no. Somehow DD will, where? This will rotate like this, okay? This direction.
This is to shift, right? Like just now I
Shift.
asked you.
So then AA, this will be DD, and this will be CC, this will be BB. It will be like this. Okay? Understand?
Yes.
Okay. So now you have that first part at the final place. Okay? So what if I do this one next? If I
Means
take AND operation with this value, what will be the answer? Someone tell me?
the sound is
Answer.
this is no, right?
That's AND.
This is an and. That means you merge it together.
Mm. Yeah,
I
and
move, so the out it will be like this. Did you see? Every other things went away. Okay.
just left the AA. Yeah. Mm.
Yeah. Now this variable is still 32-bit. We just need to convert into 8-bit. It's very simple. So let's see how I do. Okay. So what I need to do is, first I'm going to type ADD part 1. So the first thing I make ADD this value. Okay, this is the address. I shift 24 bits to this direction and take the AND with, so this value 0x00 0000 FF. So now I have the required value in 32-bit. So the way I convert this one 8-bit is this one. So first you have to put two bracket here. You have to open a bracket actually. So just say here unsigned int 8. Whatever here will be converted to 8-bit. So let's say our address is like AA, BB, and CC, and DD. So this one extracted 0x. Normally this is not the way I do. Just to show. This is just a comment, okay? I extracted this part using the using this command, okay? I hope you understand this part. It's very simple. So first I move 24 bits and take an operation with this one. Then after, from here it's very easy. You just need to copy this one. Then part 2. So here you need to move only 16 bits and same FF. Actually that's it. So you extracted this part. Okay, did you understand that one? Okay, and for the other case, the part 3, you just need to move it 8-bit. Because you are going to extract this part. Okay, so you just need to move 8-bit to this direction. And then, so you extracted this place. And then next part, you don't need to move, just get the FF. I'll just keep this one because it's already there, the DD part. So you don't need to move it. Actually shift it. Okay. If you don't understand something here, please tell me. Can you understand?
I think the last one is P4, right? Not P3.
Yeah. Sorry, I just copied and forgot to. Okay, that's it. Okay. Okay, let's write the function now. So we run the write enable function. Then again we need to load the chip select pin because we have the write enable function take it back. Okay, then we need to tell. Okay. Then we need to decide whether this is a 64 KB or 4 KB subsect erase. Let's say if it is 64 KB sector erase, you just need to send this command xpi exper. No, sorry. SPI exper stream. You need to tell that the stream was CFM, the SPI port name. Then the command 64 KB is DC 0x DC then you just need to send the addresses after that one. Okay, but the thing is, our function should be able to select different sector size to erase. So to do that one, what we can do is something like this. If sector size is equal 4, so you can just put if, so no need to put else if. I just put like that, okay, for the simplicity here. If it is 32, if it is 64, we know 64 is already this function, this command, and then you need to get the other commands. So the 4 KB is 21. 4 KB is 21 and 5C. So depending on the value you load here, correct command will be executed from this function, these places. Did you understand that one? Is it okay? Then we need to send the please tell me, is it okay or not? No problem. Please tell me. Can you hear my?
Can hear. Digesting.
Yeah. Okay. So no problem. Sorry, without feedback, I cannot go.
Okay, proceed.
Okay. So then you need to send the addresses. Okay. The way we do is SPI expert. Now you have the extracted parts. Okay. Okay. So the first you need to tell the SPI port name, then address part 1, and then you can send the second part, third part, and fourth part. Okay, then it's done. No, it's not done. So to erase a sector, it will take about 1 second. So you have to delay before going out of the function. Delay millisecond 1000. Okay, then you have to take back the chip select pin. So output high. So it doesn't matter, you can put anything. So now the function is okay. So the way we use this function is go to your here sector erase. You need to tell the starting address. Let's take one of the starting address from here. This 511 sector, so it's here. We are going to erase that 511 sector. So 0x 01 FF and 000 is the starting address. Then you have to tell what is the sector size. So if you want to erase the 64 KB, you have to put 64. If not, 32. If not, 4. Okay. So 64 I put. So this function should run only once, okay? Otherwise, it will be keep erasing the sector. So to do that one, I can take out this one from a while loop and put it here. So in that case, you can see when the code is start from here, this function will run, and then it will while loop will we keep running, okay? So it's a very simple. Then we have to write two different functions. What is those functions are byte write and byte read. So let's first write the byte write function. Byte write function will look like this. Fm byte write. So we give the byte address and then data, the data you are going to write in that place, okay? So the first thing you need to do is you need to send the byte write command and then start address. No, not start address, it's the byte address. And then third one is the data. You have to send those things according to this order. So the way we do is this, like this. First, we need to find the byte write command. Actually, it's don't say as a byte write command. It says page write command. Okay. So somewhere is, as I remember, is 1, 2. Let's find. We need to find the 1, 3 byte read write operation. Okay, read register. Clear program operation. Okay, here that is 1, 2. It says program operation, but it's actually writing. Okay, that's 1, 2. So the function I'm going to create is form void. It is not going to return anything. That's why it's void. Okay, void fm byte write. So here we need to still give the starting address, not starting byte address, add, and then the data. In unsigned int 8 data. Okay. So then the first thing again, you need to extract the address like before. Okay. So we need this part and we put it here. Then we need to write the byte write operation. So first again we need to load the chip select. This is int chip select pin. Then we need to send the byte write command. Okay, the way we do is I send 1, 2. Byte write command is 1, 2. This is byte write command. So then we need to send byte address. Okay, so similar similar to previous case, I can take this part. Okay. Then we need to send the data you are going to run. Sending the data to that byte. So that is, this is how it is done. So another SPI expert command. Here now you send the data you load here. Okay, data, and then it's done, and you have to take back this chip select pin. Take back means making it high again. Okay, this is, so the now is it okay? Okay, first thing, I extracted the address bytes, and then I want to make it write enable. Then I make the chip select low again and transfer the byte write command, and then send that byte address and send the byte data, and it is returned. So I take back the chip select pin. Okay, is it okay?
Give me 1 minute, huh? Okay. Okay.
Okay. So the way we use this function is like this. Okay, I'll show how to do. Okay. Okay, let's say we have an array like this. Unsigned int 8 array. Let's say 4-byte array. 4-byte array. I defined that one because I need some data. Let's say our data is 1 1, then 0x 2 2, and then 0x 3 3, and our data is 0x 4 4, something like this. I'm going to erase this this line. Okay. Okay. So the way I use that one is like this. Wait, I need to do something. So way I use this, I can use like this. Let's say my function is fm byte write. So let's first erase the first sector. If you using this function, you can erase the first sector, and here I can write the byte. Okay, fm byte write. You have to tell the first address 0x00000000. Then you can okay, just let's write something like this 0x11, and the next location address is 00001. Okay, then there we write 22. Okay, then like this third location is 2 here, this is 4 here, we can write 3344, something like this. You can do it. Okay, actually this is not an efficient way of doing, but I wrote it to show how this function can be used. Instead of doing this one, we can do something else also. So what we can do is for loop. We can write a for loop for int I equal 0 to I until 4 and I plus plus. So here take fm byte write. So you have to tell the address. So one more thing I need to correct here. This one. No, actually no need to correct here because I'm putting a lower bit value in higher bit, it will not create any issue. So then array something like this. So this array is saved from in this location, and this location, and this location. Okay.
Okay.
So you will see many many ways we have used in the code. Basically, this function is anywhere in the flash memory you can write the data. Okay, but you have to remember the where you are going to write that sector need to be erased before, so that it is done in this function. So
Okay.
then when you read the code, you will see this thing because you know now, you will understand. Okay. Now then we have to write the byte read operation. Okay. This one is going to output a value. Okay. Okay, I'll show the byte read function how it looks like. Byte read function will look like this. Fm byte read. So we just need to give the byte address. Yes, it will return the value of that byte address. Okay. The first thing we need to do is send byte read command and then send the address. And third one is read the incoming. Okay, this is the order. So first thing, we write the function here. Since this is going to output 8-bit variable, this is output unsigned int 8. Okay. In int 8 fm byte read. So again, the value we are going to use here, the load here is 32-bit because it's the address. We have to define it as 32-bit add.
Same as
So
the right one.
huh?
I mean, same as, is it same as the right one just now? The right function.
Right function is a void, but we need to give the data. So byte data you have to provide. This is you just need to provide only the address. Okay.
Okay, address.
Yeah. So again, I have to extract the address again. So I just put it here. Here you don't need to send a write enable function because this is not a write enable. It's a read only. So then
Output low.
first, yeah, output low. Then the first thing you need to send is
Address.
actually sending byte read command.
Oh, okay. Byte read command.
Otherwise, if you just send the address, it don't know what
Okay,
to do.
okay.
So there is something called page read or something. As I remember, it was 1.3 somewhere. Page 1.3. Here 4-byte read. Actually, this 4-byte means so you are using you are using 4 byte for the address. Okay, that's what it means. So there is a mode called 3 byte address. So in that case, you cannot access whole flash memory. You have to use the 4 byte method to access the whole flash memory. Otherwise, you will not see 100 to 8 megabyte. You will see only, I think it's 64 megabyte or something. So that's what it says 4 byte. Okay. So we need to send 1 3. So here 1 3 byte read command. So the library is already written, is there, but it's better you understand how it happens. Okay, that's why I'm doing it again. So you send the byte read command. Now sending address. Sending byte address. So again similar. Then you need to get the response back. Okay. So again I define a variable unsigned int 8 response. Is it COS for the response? I forgot the spelling. Just it's actually SS. Okay. So this is correct. Response, I define a variable called response, and then response. I just need to put this part only to read incoming data. So then it's done. I will take back the chip select pin. So here, read incoming data. I will take back the chip select pin. So it doesn't matter you type capital or simple here. I told you before. And then you have to return the data you got. Return response. Okay, the function is written. So now let's see how to use this function. Okay, let's take out this part. I will enable this one again. You understand here? First I erase it and I write 1 1 2 2 3 3 4 4. We can read these bytes again. The way we do is we need a printf function to print somewhere, otherwise you don't see it. The debug port we will print. So byte 1. So since it's a hex value and a new line function, you need to use that function byte read. Then byte read, we need to put this address. So similar way, 1 2 3 4 addresses you need to load it correctly, otherwise it will print the same value. Same value means the 0th location. Okay, I think here is 3. So when you turn, where is the issue? Debug. If print F, it's not print, just print. So when you turn on the PIC IC, it will print byte 1, 22, byte 2, byte 1, 11, byte 2, 22, byte 3, 33, byte 4, 44. Okay. Or if you want to do something here, you can just run and save in some value. Char variable. One more thing I need to tell, this char and unsigned int 8 are same in this compile, okay? Char is a character has 8 bits, so unsigned int and char is equal. So you can just define char as char also, okay? So the value in this location will be saved in variable. So you can play with this function. So that's it actually for the flash memory. Very simple. But this flash memory has lot of other option, okay? So I will show one problem in this code, okay? Let's say if I want to write a byte, every time I have to do these things. This is not good. It will take some time. For every byte, I have to extract the address, and I have to do the write enable. I have to transfer the address. So many things I have to do to write a one byte. Instead of doing this one, there is a way you can do only. You have to do this one only one time, and you can keep feeding data to the flash memory. It will automatically write in the one location. Next byte will be right in the next location. It will automatically increase the location. You don't need to send this address every time. So there is a way to do that one. So you can read the data sheet. Maybe you can write a function for that one. So in bus X we use that also, but always I trust this one because this method work in the space already tested. So I will show you one of cache memory. Sorry, did someone tell anything?
No. Just continue.
Okay. I will show you one of the bus X code. Then you will see this library, okay? Similar to this library. Uh, Give me 2 minutes. I need to get it.
It's okay. Just take your time.
It is downloading from the server, so it will take some time. Okay, this game. So this is the bus X main pick code. Where flash memory. If I go to the flash memory, it has 3 flash memories. For can you see this one?
Yes, can see.
Okay. Yeah. It has 3 flash memories. Because of that one, we need 3 SPI ports. So you can see the SPI ports are defined. And then we need I have written main FM write enable, com FM write enable, mission FM write enable, because there are 3 flash memories connected to the uh, main pic. So then you can see main flash memory sector erase is similar. So you can see, and the right enable function, lower the chip select pin, then depending on the sector size, I do this one, and then transfer the address, then take back the chip select pin. So everything similar. So this is home FM sector erase, mission FM sector erase, and main FM byte write, and byte read function, and then mission FM byte read function. So after here, this is not in the any burst or kitsune. These are new flash memory function to avoid that every time start address byte address transferring. So it's little bit harder library written there. So if you understand and play with this flash memory, later I can send this library. So this is little bit complicated one. Okay. So one more thing, in this code there are many comments written correctly. Did you find any comments in the burst 3 code? Maybe not clear comments. So if you read this code, this has the comments. Maybe I can send this one to you, but I have to talk with the BusX team before sending, because it is not even in the space yet. So I have to ask this one. So there are many comments. So that is the beauty of this code. Other code, bus 3 maybe don't have enough comments to understand.
So can I say the programming you have space proven programming and also not proven, is that?
I did not.
I mean, space proven means that already fly
Worked.
and work. Yeah.
Yeah. So this one not yet tested. So it's
I
not
see.
good.
Even programming also got this type, space proven and not.
This is not actually this. One more thing. Maybe I can give the Kitsune code. Kitsune code is better code.
Kitsune confirm is okay, right?
Yeah, Kitsune code also I can share with you. So maybe you can check that one. So how many is what time we should start? Stop?
4 o'clock. 4
4
o'clock.
o'clock. So
Maybe
16. So
can you also share with us this but even not space proven also, can you share with us so that we can also have a try?
So what I can do is, maybe not the birth sex. I need to ask the birth sex, but I've sent the Spartium code.
Okay.
So it has the reset pick code and everything is there.
There's the Spectrum that sent with the Kitsune.
Okay, one more thing. Kitsune satellite had 2 satellites inside. Okay.
Yes.
So wait. I need to explain.
You mean?
Kitsune was not a one satellite. So if I draw the Kitsune satellite like this, we had camera in 3U section. Okay. The camera controller part was a 2U. Okay, 1U. This had its own OBC, own FAB, everything. This is actually the Kitsune. There was another satellite here. It's a 1U. QTech had a satellite called Spartium. It was a 2U satellite. This satellite name was Spartium 2. So that satellite just get only power from this direction. There are no communication in between. Okay. So that's why I said I forgot. So this Kitsune code may be little complicated because it's a different system. This Spatium is almost bird satellite
Oh, okay.
with the advanced code. Okay, so it's a one, basically two satellite together in a one satellite, in a one package. So after this meeting, maybe within half an hour, I can share. I will send the that codes to WhatsApp. Okay, you can share.
Thank you.
Okay.
Thank you.
So the next day,
Next day.
let's discuss the reset fig code, the one I am going to share with you. Okay.
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 Okay. So then see you Monday.
Yeah, thank you very much.
Thank you very
One
much.
more thing. I think I will send the code I just wrote. Okay.
Yeah.
Yes, yes.
you.
Okay.
Flash memory. Yeah.
Yeah.
Okay. See you Sunday.
Yes. Thank you.
Monday.
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 Yeah. Sorry.
Okay. Tadi you baca you nggak yang the latest